Well, good afternoon. Good afternoon, everyone, and welcome to another Tool University virtual demonstration brought to you by Rhino Tool House. This is our 6th week of these live demos, and we're glad you're able to join us today. These all started in the north, they've circled through the south, and now they come back up to the north since the ice is out. We hope you found these events to be educational, informative, and fun, especially during these interesting times. Big shout out to our marketing department for all their hard work in putting these together. Please allow me to introduce Randy Paulson, our Panasonic Regional Manager, and myself, Skip Young, Sales Engineer for Great Plains region of Rhino Tool House. A little bit about Rhino Tool House. I think its simplicity says it all. Our mission statement says it all. Our mission is to identify and deliver the world's most innovative industrial solutions. Which brings us to today's Tool University focus. How to enable and drive your operation to create a no-faults forward process with reactionless single handheld tools. But before we get started, consider these questions. Do you have applications where a tool torque reaction is an issue? Do you have applications where the operator needs to hold a part in place during the fastening process? And do you have applications that knowing the correct torque has been applied to the fasteners and the fastener batch count is right? If you answered yes to any one of these questions, then today's discussion is an important one for you and your company. Please note during this presentation to select the side-by-side view on your PC. You'll see it's a drop-down menu. It's easy to see and find. Also, please note to type in your questions into the chat. We will make sure to respond to your questions during this entire demonstration. Randy will begin with a brief PowerPoint to illustrate Panasonic's innovative technologies, and we'll have a live demonstration for you later to see in this technology in action. I'm now pleased to hand off the baton or virtual baton to Randy for this virtual demonstration. Take it away.
Thank you, Skip. Thank you, Rhino Tool House. Thank you, everyone, for joining us today for this virtual demonstration. Today, we're going to talk about Panasonic cordless error proofing. Panasonic makes a wide range of cordless tools. We provide torque control from 1.4 inch ounces all the way up to 1,000 Newton meters. And today, we're going to be talking about the AccuPulse HR series of mechanical pulse tools, reactionless error proofing. If you're looking at this slide right now, you can see 9 reasons why customers have used our AccuPulse tools. The first one is ergonomics. We manufacture cordless, reactionless tools, like I said, up to 650 Newton meters with no torque reaction. So you can assemble with one hand and have 0 sprain injuries. I think a sprain injury costs a medium-sized company about $30,000, and we can help your manufacturing process avoid those sprain injuries. Trip hazards. I go through factories and I see so many air hoses or cables around equipment, and sometimes the height of the fall is rather large, and we can eliminate those trip hazards with an air hose or a cable. Improved air quality. If you have an ISO 14001 standard, you will really be interested in the Panasonic, how we can save and cut your CO2 production substantially. When you look at durability of the Panasonic tools, we test them to over 2 million cycles, and we make every effort to take out every wear point. Our batteries typically last on one shift up to 6 years. That's based on 250 production days and 1 charge per day. Some of the energy savings that we'll see, and I'll present a cost savings calculator, and if you want a copy of it, you can ask Skip or your Rhino Tool House representative to send you the cost savings calculator. You can run about 100 of the Panasonic cordless assembly tools off the energy of 1 air tool of the same size. Sometimes air plants, when they go into their shutdown, assembly plants, you can even hear the air leaking out of certain connections, and those will be avoided, and fluctuations of air pressure will be avoided with cordless tools. And lastly, our tools are very easy to install. I'm going to go into some of the cost savings for maintenance right now. If you compare another version of reactionless tools to ours, the most common is an air pulse tool. The air motor and the pulse unit has a rebuild kit that costs. the preventative maintenance on the actual labor charge and the equipment brings each oil change on a hydraulic pulse tool up to about $714. On a cordless Panasonic tool, you're talking about a 15-minute process and very simple parts and $132. So if you take those cost savings and extrapolate them over your number of assembly tools in your plant, you can save $582 per tool per year based on a 100 Newton meter application with 1 million fasteners. This is the cost savings calculator that I talked about, and we populated this cost savings calculator for a 2-shift production, and I think it's 4 fasteners per vehicle, and then we totaled in the hours per day, and we came up with $829 per tool that you convert from an air tool to a cordless tool. The air cost is $829, and the cordless tool costs $15. So you can save a lot of money. Now I get into the HR portion of the presentation. A lot of you are familiar with our mechanical pulse tools and you're running them currently. Thank you very much. They have the black handle. The new AccuPulse tools have a gray handle. And here are some of the changes that we made in the tools to make them faster, quieter, and more accurate. We actually went to a high-resolution angle encoder that monitors and predicts the position of the anvil 8 times faster. Formerly, we were monitoring the motor speed about 12 pulses per revolution. Now we're monitoring it 100 times per revolution. And we're predicting the angle 0.4 times every 0.4 degrees. So you can see we're 8 times faster. This slide has 3 portions. So I'm going to talk about the first portion now. Our mechanical pulse tools had 2 algorithms and 30 torque stages. And what we do with the Panasonic tool is we sense when the part is flush. So you can see on the bottom of your slide, we're going to sense the flush condition based on the speed of the motor and the frequency of the pulse. And then we're going to rotate so many degrees after that and shut off. Let's say your target torque in the red box is 47 Newton meters. On a hard joint, medium hard joint, you go to flush, you rotate your angle, and you shut off at 47 Newton meters. Now let's go to the next slide. Some of you have experienced some of these problems with our mechanical pulse tools. You might have prevailing torque from a nylock nut, from a thread friction modifier, from 2 parts that are bowed. Let's see, what else? Lock washers. But you'll have something in the fastener that is producing prevailing torque during the rundown. With our former mechanical pulse tools, they would sense the flush point on L2, rotate the angle, and shut off at that example, maybe about 20 Newton meters. So if you go to the next slide here, you can see that with the additional algorithms up to 7 on the left side of your screen, we can actually increase the algorithms to make sure we're getting the flush point during the rundown. And when we go to our angle calculation through your remote control, settings 1 through 40, you actually get your target torque of 47 Newton meters. This has enabled us to go back to existing customers like yourself and new customers like yourself and do prevailing torque applications that we formerly could not do. Now I want to get into the other equation of the AccuPulse HR, and that's the qualifier. You know, we're talking about Industry 4.0. We're talking about controlling what you're doing, when you're doing it, and how many fasteners you are assembling in your process. And that's where the qualifier comes into play. Now with the two-way communication, we can actually send all of the elements in the gray portion of your screen can be sent from your MES system through the qualifier and to the tools. So now you can see the most common things that you want to send and receive from the qualifier is your okay, not okay signal. The next one is, hey, I want to change my torque setting. I've got 10 fasteners across this panel that's closing off this part. And some of them have lock washers, some of them have paint, some of them have 5 thicknesses of material, but they're all 47 Newton meters. Now you can actually control your torque parameter as you go through your fastening strategy, and you can have it send a different parameter to the tool and count the number of OK, not OKs. I'm not going to cover every bullet point in this gray area, but you can see those elements can be sent from the line control and programmed from the qualifier. When it comes to the multi-tool controller, I wanted to also mention that we do have clutch tools from 2 to 10 Newton meters, and we've added some new protocols. Down in the bottom left of your screen, you'll see Profinet is added, and you'll see Chrysler PFCS is added. Ethernet IP is very common, Open Protocol is very common, ToolsNet is very common. And we can communicate with your protocol and your PLC for Industry 4.0 error proofing. We like to call this, in this virtual age, right? We're all doing virtual presentations. We can't wait to get in front of you on your assembly line or in your plant. But until then, we have a virtual socket tray. When I do a demonstration later on, you'll see the tool with the flashing indicator for which tool the operator is supposed to pick up. And then when they're done with that number of fasteners, it'll prompt the operator to grab the other tool. So it's like a virtual socket tray. Now, we have 2 qualifiers on this screen that you're looking at. You see the O3A and the O4A. Just the brief difference is the O3A can run groups. It can run 16 tools in any order, controlled by your MES system or controlled by a recipe in the qualifier. The O4 qualifier can run 4 separate sequences, we call them jobs, simultaneously. I had a customer that was building engines, and they had test stands, and they had trim and additions that were done to the engine after assembly. They wanted to be able to control sequences on 4 test stands simultaneously. Our former qualifier, we had two-way communication. We could send different signals, but they still needed 4 qualifiers. We've cut our cost to you by 75% or down to 25% because the EYFR04A can now run 4 different sequences simultaneously. And as you'll see in the demo, the right tool flashes when it's supposed to be ran by the operator. All right, I'm going to do a brief demonstration here. So just imagine that your MES system just sent a command to do job number 1, that's sequence number 1. In job number 1, this tool is flashing, and it's going to have it run at about 3 Newton meters, setting number 1. It's going to run 1 time. It's going to give you a green light in the qualifier and in your data. And then it's going to lock that tool out and command this tool to run with the flashing indicator at parameter 3. Then it's going to lock that tool out and drive this tool to run a higher torque parameter the last time. I'll go ahead and do that presentation now. I got a green light on the tool. I don't know if you saw it. Green light on the qualifier. And now it says process complete on the tool, and it will not run. So if the operator wants to run another fastener with this tool, they cannot. This tool is flashing, and it's on torque parameter 2. I don't know if you can see the torque parameter 2, but you'll notice the first tool will change when I do that application. Green light on the tool, green light on the controller, and now this tool is locked out. Cycle complete. This tool is flashing with a light on the tool. So if you had a dozen tools laid out, you would actually see the operator pick this tool up, and it changed from parameter 1 to parameter 5. I run down, get a green light on the tool, green light on the part. Both tools are locked out, awaiting your next assembly process. So that's the portion of our live demo. If you have any questions, we can field the questions. And then also, I wanted to kind of let you know that we have a complete line of torque testing equipment. And you can see off to my right, hopefully, this is a screenshot of our torque tester. This is the 22 Newton meter torque tester right here. And so we have a full line of torque testing, and they can monitor a mechanical pulse tool, a hydraulic pulse tool, DC electric, clutch tool. They can handle any form of assembly tool with the double bearings and the robust technology. So this is our torque tester. I wanted to let you know. If you would like a demonstration in your facility, please let the Rhino Toolhouse team know.
Thank you, Randy. A couple questions here. First one, what's the max torque that you can do reactionless?
Oh, great question. 650 Newton meters is our EYFPA1J. And if you put an R on the end of the model number and a T, it has the two-way communication with the radio, 650 Newton meters.
Perfect. How many parameters can the qualifier store?
Okay. The qualifier can hold 100 P-sets or parameters, and those can be configured into groups or jobs based on which qualifier you have. But 100 P-sets can be loaded and demanded by your MES system.
Perfect. Question from Nick here. Do you offer any hybrid tools that can be run in either clutch or pulse mode by changing the tool configuration?
A great question. Thank you very much. Not at this time. I won't disclose everything that's in development, but stay tuned and keep asking us to your factory, because we're developing new equipment and it'll be introduced shortly.
Perfect. Question from Patrick. What is the quoted torque accuracy of a medium joint with the new generation pulse tools?
Okay, great question. Yeah. Our mechanical pulse tools had a black handle, and we rated those at 20% plus or minus. They would do 5% on a real repeatable joint, but we came out with the AccuPulse tools, and we've found that we can very consistently run in a 10 to 15% repeatability range.
Great. What is the lifespan of the battery?
Oh, nice. We met in a 250-day production year. And if you charge it once a day, we rate our batteries for 1,500 charge-discharge cycles. So that comes out to be about 6 years. With Panasonic manufacturing so many batteries, like I say, 220 billion battery cells since 1931, we really have provided a safe, long-lasting battery solution to customers, and it really generates a lot of cost savings for you.
Question about the demo
Note is we actually make all the battery cells for like Tesla automobiles, and we just have a great reputation for a safe, long-lasting product.
Perfect. Another question here. What did the 5 refer to during your demo?
Oh, great question. All right. I'm not used to that many good questions. All right. So what I'm going to do here is I'm going to change this on the qualifier to the parameter. And I think that was parameter 17, I believe. So I'm going to go down here and edit. Okay, yeah, 5. And that was on tool number 1. There we go. Save, select. Okay, I just changed the tool, and normally that would have been done in the MES system. And what that 5 represents is there's 40 torque stages and 7 algorithms. We have graphs that show that linear for a medium hard joint, a hard joint, a soft joint. So there's 40 torque stages. So you divide your 40, and 5 is going to represent on this tool about that 5 or 6 Newton meters on a medium hard joint. If you had a soft joint, that same number 5 is going to probably give you 4 Newton meters. That's why we always recommend that you set these on the application with a static torque audit, so you get your CPK with your socket, your extension, and so on and so forth. So the 5 represents a ratio of your 40 settings, which correlates to a torque setting. Hopefully that answers your question. If not, send in another one real quick.
Perfect. Question from Mike here. How do you get out of a sequence between tools after a torque is qualified?
All right. How do you get out of a sequence between tools when a torque is qualified? Okay, if I understand your question correctly, You can lock on batch in your program, or you can choose not to lock on batch. If you lock on batch, after you finish your sequence, everything is going to halt, and you'll get that lock symbol that I saw in the qualifier earlier, and the tools will be locked out. So if you select lock on batch, it happens automatically. If you don't select lock on batch, it will keep cycling through. The third option, and this was one of the real reasons one of the large customers of ours wanted the two-way communication. They wanted to be able to enable and disable the tool. So with our two-way communication, the very first thing we did was have the ability to lock out the tool when we wanted to. That was even before two-way was sending the parameters. So there's 3 ways you can do what you just asked, and the most common is having the MES system send a lock tool command and then send a parameter command when they want to start.
Perfect. Thank you, Mike. Another question from Patrick. Can you program the same tool on the same controller with different L levels / algorithms?
Great question. All right. So yes, you can. You can have 100 different P sets with each tool. And so you can, what you need to do is tools 1 through 16, and I don't know if you can see the qualifier screen, but I'll just walk through. Tool 1 through 16 is hard-coded to parameter 1 through 16. So I don't know if you can see these boxes, but this is a 4A qualifier. If you want to go with a second parameter on any given tool, you start with number 17 and higher. So yes, you can. And so when your MES system says run parameter 17 4 times, okay, when you get your 4 OKs, it locks that tool out. Now run parameter 18 2 times. It puts those 2 OKs, locks that out, and you can do that up to a different 100 different P sets per tool with the O3A. Great question.
Got one more question here. Could a VIN number or a barcode input to the qualifier controller, the torque setting and bolt count?
Okay. All right. That's on the side of the qualifier, we have our inputs for barcode or Ethernet connections, and we can take an input from a barcode reader. You can plug a barcode reader right into the qualifier, or you can have your VIN number go to your MES system, and you can have that tied to the data. So yes, and you can actually build in a smart barcode. So when it senses if the third digit is a 1, do parameter 1 4 times. If the third digit is a 2, do parameter 5 2 times. And you can build that intelligence into the qualifier. Most customers I've found, the larger they get, they hold all that in their MES system, and then the smaller companies allow the qualifier to be their MES system. Great question. You can do VIN numbers, you can do barcode numbers, and you can have it control your torque parameter and the number of times that you run that parameter.
Perfect. Another question, or a question from Kevin here. You talked about virtual socket trays. Do you do actual socket trays?
Great question. I wanted to say yes to everything today. Not yet. In some of our products, like the HS Technique, we have socket trays. We do not have a finished product with a socket tray for our qualifier yet, but anyone can connect inputs from any device. So if you wanted to connect your socket tray to our qualifier is looking for a binary input, high or low, and that's what selects the parameter. So we don't care if it's a rotating switch, we don't care if it's an input from your MES, we don't care if it's a socket tray. But right now we're putting that protocol effort on you, but stay tuned. We will have some new things to show you shortly. But until then, just have your Rhino Toolhouse team orchestrate a remote parameter selection like a socket tray for you.
And a follow-up question from Kevin. How many inputs and outputs?
Okay, all right. So there are 8, without the I/O expander, there's, I think it's 8 inputs and 8 outputs. And if you send your request on an email to one of us, we'll make sure we get you the right answer. We'll send you the programming manual. I'm going to go with 8 and 8 right now.
Final answer.
Yeah.
We do have an I/O expander that you can expand substantially after that.
Yeah, we do have your info, Kevin. We'll make sure to get you some documentation on that.
Thanks.
Looks like that's the last of the questions, unless anybody else has a follow-up or a question they'd like to ask. You guys can take it away.
All right. Well, again, thank you very much for joining us today. We truly, truly appreciate you carving out time to join us. As a follow-up, please contact your Rhino Tool House engineer, a sales engineer. We'll work with you. We'll come visit your site if that's appropriate at the time and review the application or maybe do it virtually. Be sure to be tuned in tomorrow for tomorrow's topic. The future is now with augmented reality light guide systems. Improve quality and your first-time yield and kitting applications by implementing augmented reality. Thanks again for joining us. Take care.